Welcome back, my students. How are you all? I hope you all are fine. I am Sir Sunil, your physics teacher, and today we are going to start your new chapter, Energy. All of you take out your book and ready to watch video. Okay, students, here is our new chapter, Energy. We have read that a force when applied can move a stationary body. Stationary body means what? Stationary body means the body which does not move. In that particular body, if we apply a force, either push or pull, it starts to move. Then easily we can say that we have done some work on it. If the body does not move, if the body does not move, if you are not applying a push or pull on it, it does not move. Means that if you are not doing any work, no work is done on it. Okay, students? So the work done by a force is measured by the product of the force and the distance moved by the body in the direction of force. So we can calculate the work done by using the formula work done is equal to force into distance moved in the direction of force. Clear? Work done is equal to force into distance moved in the direction of force. By this relation, we can find out the work done. Okay? The SI unit of force, that is Newton. We know that the SI unit of force, that is Newton. And also the SI unit of distance is meter. The symbol of Newton, that is N. Clear? The symbol of meter, that is M. Okay, we know that. Okay, students, the symbol of Newton, that is N. The symbol of meter, that is M. So by calculating these both, by considering these both, the SI unit of work will be Newton into meter. By considering the above units N and M, we can say that the SI unit of work will be Newton into meter, which is written as Joule after the name of the scientist J.P. Joule. The seat memory of the scientist J.P. Joule, we are giving the SI unit of work is Newton into meter, that is Newton meter. In short form, we can write this one as 1 Joule is equal to 1 Newton into 1 meter. So we can give the definition here. 1 Joule of work is said to be done when a force of 1 Newton moves a body by a distance of 1 meter the direction of force. So what is the definition of 1 Joule? Okay, 1 Joule of work is said to be done when a force of 1 Newton moves a body by a distance of 1 meter in the direction of force. When work is done on a body, its energy increases. When work is done on a body, its energy increases. In other words, we can say that the work done on the body is stored in it in the form of energy. The work done stored in a body, that is stored in the form of energy. But if work is done by the body, its energy decreases. In other words, energy is spent when the body does work. If work is done by the body, its energy decreases. So we can say that energy is spent when a body does work. Example. Here one example, we can go through it. Please go through it. When a girl rides a bicycle, see, one girl is riding a bicycle. You just observe it. It's a familiar example. When a girl rides a bicycle to a distance, she spends energy in doing work. If you are riding the bicycle, we know that we are spending energy there. Here also, same as it is, this girl spending energy. She will continue to ride the bicycle and do work till she possesses energy. We also same as it is. If you are riding the bicycle, we are also spending energy. And now we can define energy as follows. Okay. Energy is the capacity to do work. Energy is a capacity to do work. So finally we reach the definition of energy here. Energy is the capacity to do work. Clear? Then what is the relationship between work and energy? What is the relationship between work and energy? Okay, students, you must have read that. You must have experienced that. More you ride on a bicycle or more you run all around the playground, more you feel tired. If you are riding the bicycle more, or if you are running the ground more, if you are making the 2 or 3 rounds in a ground, what will get? Will tired. The reason is that a lot of energy has been spent in doing work by us. That's why we are getting tired. Okay, students. So the reason is that a lot of energy has been spent in doing work by us. Thus, to do more amount of work, what we have to do? We have to do more work. You need more amount of energy. Means we need a more amount of energy to do more work. Hence, we can say that there is a direct relationship between work and energy. So we can say that there is a direct relationship between work and energy. Similarly, the work done on a body in changing its state is said to be the energy possessed by the body. We can say that the work done on a body in changing its state is said to be the energy possessed by the body. For example, if a body is moved from the ground to a height, work is done on the body against the force of gravity, and the body at the height is said to possess the energy. Clear? If a body is moved from ground to height, clear? Work is done on the body against the force of gravity. Always we know that every object attracts to the earth by the gravitational force. But if you are moving a body, clear, if you are moving a body from ground to height, we are applying a force against the gravitational force. Okay, then also here possess the energy. Similarly, if a body initially at rest is made to move, work is done on the body, and the body in motion is said to possesses the amount of energy equal to the work done on the body in producing motion in it. Now we are going to discuss about the point units of energy. Units of energy. We know that energy is measured. Energy is measured in the same unit as work. Therefore, the SI unit of energy is a joule. The SI unit of energy is a joule. The symbol of joule, we know that is J. Okay, the symbol of joule, that is J. A body is said to be move. We know that we have to do some work. A body is said to possess an energy of 1 joule if 1 joule work is done to bring the body in that state. That is, a force of 1 Newton moves the body by a distance of 1 meter in the direction of force. Okay. So, another unit of energy is calorie. Another unit of energy is calorie. Symbol is CAL, where 1 CAL is equal to 4.2 joule nearly. 1 calorie, that is 1 CAL, 1 cal, that is equal to 4.2 joule nearly. A bigger unit is kilocalorie. A bigger unit is kilocalorie, that is kcal, where 1 kcal is equal to 1000 cal. More preciously, more accurately, we can say that 1 cal is equal to 4.18 joule. Okay, students, today we are going to wind up the class. Tomorrow will come by the topic different forms of energy. Different forms of energy. Till then, goodbye and have a nice day.